For this lesson, we're going to be looking into the graphs of quadratics. And we're going to be doing it through an investigation. And we're going to go through a bunch of different examples, and then we'll make some conclusions at the end. So there might be a few in here where I'm just going to give you some of the information, and then you're going to have to quickly pause the video and try some of it on your own. So it might be a little bit different than usual, but I think you'll be able to get the hang of it. So our first investigation here, we're going to be looking at the equation y equals x squared. And this equation right here is what's called our parent function. And we'll also be referring to it as our original. So this is going to be the parabola that everything else is going to be compared to. So this is the original one with nothing else changed to it. So we're going to go through the whole process of what our investigations are going to look like for this first example, and then the ones from here on out, I might have to skip a couple steps in the video just so it doesn't drag on too long. So the first thing that we'll be doing is we're going to be graphing using a table of values. The whole idea of this lesson is to get to a point where we can graph without a table of values, but for right now, we'll have to go through the whole process of creating the table. So just as a reminder from last lesson, in order to create a table of values, I'm going to rewrite my equation, but in this case, I'm going to fill in something different for x. And in this row, I fill in -3 for x, and that will give me y equals 9. For the next row, instead of writing an x, I'm going to write a -2, and that will give me y equals 4. And you're just going to continue putting in all of your x values until we have filled out all of the y values. So I'm going to skip ahead and I'm just going to write out the other ones. But if you want to pause the video and go through them step by step, that's totally okay. So now that we have our table of values, we're going to plot all of these on the graph over here. So I have 0, 0, 1, 1, -1, 1, 2 and 4, and -2 and 4, and 3 and 9, and -3 and 9. So we should have something that looks like this. And you'll notice all of our parabolas should have this kind of curved U shape that looks kind of like a smiley face. That's the shape that we're going for here. Now there's going to be, for all of the parabolas we're going to be drawing in this lesson, we're going to be looking at 3 things. So the first thing we're going to be looking for is the vertex. And we briefly talked about that last lesson, but I want to talk about it again. So the vertex is this point right here. It's our turnaround point. So all of our parabolas are always going to be symmetrical. And if you look at our table of values, you'll notice that I go 9, 4, 1, 0, and then it turns around and I start repeating numbers again. That is the turnaround point of the vertex. So that point there that I've highlighted is our vertex. So I'm just going to write those coordinates right here. And the second thing we're going to be looking at is our direction of opening. So is it opening facing up or is it facing downwards? In this case, it's facing up. And I like to think of those as like a happy parabola. It's like a little smiley face. So those are upward facing ones. Now the next part that we're going to do that is new is our step pattern. So in grade 9, you worked with rise over run a lot, and it was a very important component in graphing your lines. For parabolas, we're going to use what's called the step pattern. And basically what our step pattern is it's how our parabola grows. So in order to find our step pattern, you're going to take your pencil and you're going to put it right onto your vertex. Then from your vertex, you're going to go right 1, and it's always 1 to the right. And then you're going to take your pencil and you're going to go up until you hit your graph again. In this case, I went over 1 and then I went up 1. So that means for my step pattern, I go over 1, up 1. Now I'm going to do it again. I go over 1 again, and then I take my pencil and I go up until I hit my graph again. And in this case, I went over 1, up 3. And then I'm going to do that one more time. I go over 1 and I bring my pencil up and I go up 5. So our normal step pattern of our original parabola is always over 1, up 1, over 1, up 3, over 1, up 5. And this is a really good way of being able to have one point and then we can find all the other points on the parabola. So those are going to be the three main things that we're looking for in all of our parabolas. And now we're going to start investigating some changes that we can make to these. So for the next one, again, I have done some of the pieces already just so that our video doesn't take forever to get through. So just bear with me and you might need to pause the video just to catch up with what you need to draw. So for our second investigation, I've already done the part of filling out our table of values and graphing these. So the first one is the pink example, and that is y equals x squared minus 3. And I went through and I filled out the table of values the same way we did above. So you can go through, pause the video if you want to, and fill those out. And then I just plotted the points. So for the pink one, we'll just focus on the pink one for right now. We're going to start by identifying our vertex. So remember that vertex is that little turnaround point right there. And so in this case, our vertex is at 0, -3. And then we look at our direction of opening. Is it facing upwards or is it facing down? And in this case, it's facing up. And now we want to address our step pattern. So remember for our step pattern, we put our pencil right at the vertex, and then we go to the right one, and then move your pencil up until you hit the graph again. So in this case, I went over 1, up 1. Then again, move your pencil over to the right and move it up until you hit the line again. And then we went up 3. And then we go over 1. We move our pencil up until we hit the graph again. And we went up 5. So in this case, our step pattern has not changed, and that is absolutely okay. So now let's address our orange one. So for the orange one, my vertex here is our turnaround point. So I'm going to highlight that. And our vertex here is going to be at 0, 2. And the direction of opening for this one is also going to be up. And then again, we need to find our step pattern. So we put our pencil right on the vertex, over to the right one, move our pencil up until we hit our graph again. So again, I only moved up 1, over to the right, up, and I moved up 3. One more time, and I moved up 5. So again, our step pattern has not changed. We just went up, over 1, up 1, over 1, up 3, over 1, up 5. So now we want to get to our conclusions, which is really what this whole lesson is about. So in our equation, the difference from our original, so just as a reminder, our original was y equals x squared. In the pink and the orange equations, all I've done is I've either subtracted a number from the original equation or I've added a number to the original equation. And when that happens, if I look at my parabolas, they're the same shape, they have the same step pattern, but all that's happened is they have moved up and down. So let's go right here. So it moves the graph up if it's positive. So just like my orange one, because I added 2, it moved my graph up. or it moves it down if negative. So just like our pink one. So that's our first rule. So if I've added or subtracted, I should expect that my graph is the exact same shape. All that's happened is it's gone up a few units or it's gone down a few units. We're going to look at two more examples of our next rule. So again, I've already filled out the table of values and I've graphed it for you. Just pause the video if you want to go through the whole process of graphing these things. We're going to get into tons more graphing later, so I didn't think it was too big of a deal to kind of skip that step, but if you want to keep practicing, absolutely a good idea. So again, remember that our original parabola was y equals x squared. So what's changed here is I've subtracted something beside the x. So it's also squared. So that's the change I've made. And now I'm going to think about how that impacts my parabola. So again, we're going to look for the same things. We're going to start by looking at our vertex here. And my vertex is at 3, 0. So this is the first time we've actually saw our vertex change. So that's something to keep in mind. Again, our direction of opening is still up. We haven't changed that. And now we're going to look at our step pattern. So we put our pencil right on the vertex, go over to the right one, and up until we hit our graph. So again, that's only one. Then we move over to the right one, move our pencil up until we hit the graph, and we get 3. And one more time, and we get 5. So again, our step pattern has not changed. It stayed the same. Oops, sorry. The only thing that has changed is our vertex. And if I look at this, it's the exact same shape. It's still a happy parabola, it's still upward facing. The only thing I've changed is that now it's living just slightly over to the right. It's not symmetric with the x-axis, that thick black line anymore. It's now moved over to the right and it's living 3 units to the right. So that's our first example. Let's do another one that has a similar change. So just as a reminder, our original parabola is still y equals x squared. So in this case, I have just added 2 beside the x. And here's our graph and what it looks like. So we're going to identify our vertex again. So if you notice, our vertex has changed again. Now it's at -2, 0. It's not being separated by that thick black y-axis anymore. It's been moved over. We also want to notice that it's still upward facing. We haven't changed that. And now we'll check our step pattern to make sure it's the same shape. And we still have our same step pattern here. So that means it's still the same shape as it was before. The only difference is that it has now been moved over to the left. So it's just living in a slightly different location. So now we're going to make our conclusion here. And what is the effect when a number is added or subtracted to x in brackets of the equation? So all that's happened for our 2 equations here is that our little parabola has just been picked up and moved left or right. Now the other piece that we want to notice is that when this number here, our -3, was negative, it moved to the right. And when the number in the bracket was positive, it moved to the left. So things that are in the brackets there do the opposite of what you think they're going to do. So I'll write this out in words and then I'll kind of explain it one more time. So what happens? It moves it left if positive in the bracket. So when we had our y equals x plus 3, that plus in there is going to tell you we're moving left, the opposite of what your brain will think, or it can move right if it's negative in the bracket. So our other example, y equals x minus 2 squared. Okay, so we're going to look at a couple more. We're almost done. So again, just as a reminder, our original parabola is y equals x squared. So what I've done now is I have just put a number in front of my x squared. So I've multiplied a number to the whole x squared. And this is what's happened to my graph. So if I notice, my numbers in the table of values are a lot bigger. So let's go through and we'll do all of our steps that we were doing. We'll first identify our vertex. So there it is, living at 0, 0. Just like our basic one at the very, very beginning, that original parabola before we were moving it around. Then my direction of opening is going to be up. It's still upwards, it's still a happy parabola. And then I want to look at my step pattern. So remember, we put our pencil right on the vertex and we go 1 to the right, and then we move our pencil up until we hit our line again, which in this case, I moved 2. Now we're going to do it again. We're going to move over 1, and then we move our pencil up until we hit our graph again. And then we're going to move up 1, 2, 3, 4, 5, 6. And if we were to hypothetically do it one more time, we would end up moving 10. So our step pattern is over 1, up 2 this time. Then we went up 6. And then if we had a bigger graph, we would have gone up 10. Now, where did we get 2, 6, and 10? Well, those are our original one was over 1, up 1, over 1, up 3, over 1, up 5. But what we've done to all of those numbers is we have multiplied by 2. And where I got that number 2 from is up here in the equation. So that is what that number 2 is doing in the front. Now, in terms of how our parabola looks, it should look a little different this time. Our shape is not the same, and when our step pattern is different, that's telling us the shape is not the same anymore. So this is called a stretch. I've taken my original parabola that looks something like this, and it's like I've grabbed it and stretched it up and made it thin and skinny like that. It's like I grabbed it and I just stretched it as much as I could. That is what is called a stretch. And to be more specific, it's called a vertical stretch because I'm stretching it up and down. Okay, let's try another one. So again, I've already given you the table of values and the graph, so you can pause this and quickly add that into your sheet. Again, you'll notice that our numbers have gotten very big. So that means something major has changed to our graph. So just as a reminder, our original one is y equals x squared. So if I'm looking at my equation, what I've done is I've multiplied that x squared by a negative 3. So let's go through and fill out the chart at the bottom and look at all the pieces that we need to look at. So first identify our vertex. So my vertex is still at 0, 0. That hasn't changed. It's still starting at the same point. And now my direction of opening is different. This is the first time we saw a different direction of opening. And this time it's facing down and is, in other words, a sad parabola. So it's facing down and it looks like a sad face, so it's a sad parabola. Now let's address our step pattern again. So remember, we always start at our vertex. You always go over 1 to the right, but this time if I go up, I'm not going to hit any lines. So I'm just going to go down to meet my parabola below. So I go down until I hit that first point, and in this case I went down 3. And we'll do it one more time. We move our pencil over 1 to the right, and I'm going to move down until I hit a nice point. And in this case, I went down 9. So for our step pattern, we went over 1, down 3, over 1, down 9. And if we had a bigger graph, we would have gone over 1, down 15. Now, how do these numbers relate to anything? Where are they coming from? We're going to look at our original step pattern again, which was over 1, up 1, over 1, up 3, over 1, up 5. Now, similar to what we were doing above, all of these have been multiplied by 3. And where did I get that number 3? It just comes from my equation up here. Now, the other difference is I'm not going over 1 and up, I'm going over 1 and down, and the down part is coming from the negative here. That's what makes it go down. So let's make some conclusions here. What is the effect when a positive or negative number is multiplied to the equation of the basic parabola? So the first thing is that it's positive. When it's positive, we have what's called a vertical stretch. So we did talk about those before. And in that case, we're going to multiply by, multiply the step value and if it's negative, we also get that we can have our vertical stretch. So we also have our vertical stretch. So for example, with the graph above, you can see that it's a lot skinnier than the last one. So it's even more stretched than the one with 2. And the other thing that is different though, is it's flipped upside down. And how we write this out in math and the words we use for that is we say it's been reflected in the x-axis. In other words, it's as if the x-axis is a mirror and it was flipped upside down over top of the x-axis. But that is the language we want to use, reflected in the x-axis. In other words, upside down. So that negative in front of that 3 is stretching it, so making it skinnier, but it's also flipping it upside down. And the way I like to remember that is if it's positive, it's a happy parabola, it's positive, and then if it's flipped upside down and our a value is negative, it's a sad negative parabola. So that's the way I like to remember that. Okay, we finally made it to our last set of parabolas. So again, I filled out the table of values for you and I've graphed it. So we've done this a lot, so hopefully I can go a little quicker. We'll first find our vertex here. So our vertex is still at 0, 0. It's facing upward, and then we'll find our step pattern. Now the step pattern here is tricky to find, and in a case like this, if you had a really weird step pattern, you would probably have to figure out your a value a different way, and we'll get into that later. But for right now, we're going to go over 1, and we go up to our next nice point. Because we know our points here, I know that I went over 1, up 0.5, and then I do it again. I go over 1, and I go up 1.5, and then I'm going to do it one more time, and I'll go over 1 up 2.5. So we'll write that in the chart. Over 1, up 0.5, over 1, up 1.5, and over 1, up 2.5. Now, how did we get these numbers? Same idea as before. If I look at my original, I went over 1, up 3, up 5. What I've done is I have just multiplied everything by 0.5. And where did I get 0.5? From up here. Now, the other piece that we want to look at with this parabola is, did our shape change? If our step pattern is not the original, our shape has definitely changed. And we want to think about what is different here. In comparison to our original parabola, which looked something along these lines, our parabola looks a little bit more like this. And that's because we've multiplied it by half, so it's just increasing a lot slower. So it's a little bit wider and it just increases slower. So it's almost like we put our one hand on top and one hand below and we squished it or compressed it. And that's the word we're really going to be using is that we've compressed it. So last one, we've almost made it. Y equals negative 0.25x squared. So let's first start by identifying our vertex here. We're still at 0, 0. Now our direction of opening is down, which is not surprising because we have that negative in front of the 0.25. And now we'll look at our step pattern. And again, with these decimals, it's very difficult to see. If you were given one on a test or quiz, it would be a lot clearer, or you would figure it out in a different way, which we'll get into later. But for our purposes right now, we'll just look at the step pattern. So we go over 1, down 0.25. Then we'll go over 1, down 0.75. And then we'll go over 1, down 1.25. So our step pattern is over 1, down 0.25, over 1, down 0.75, and over 1, down 1.25. And again, in comparison to our original, which was up 1, up 3, up 5, we have multiplied everything by 0.25. And the reason that we're going downward is because of that negative there. Okay, so let's quickly sum this up and then we are basically done. So what is the effect when a positive or negative number is multiplied to the equation of the basic parabola? So this funny symbol here, this 2 bars around A, means absolute A. And what that means is ignore the sign. So when we have the sign in front of our x, that's telling us if it's a happy parabola or a sad parabola. So we look at the sign totally separate than how we look at the number. So the negative just tells us if it's happy or sad. And then the actual number, ignoring the negative, will now tell us the shape. So if our absolute A is bigger than 1, we have a stretch. If our absolute A is between 0 and 1, we have a compression. So for example, if I have 2, that would tell me stretched by 2. If I had a half, which is in between 0 and 1, that would tell me compressed by a half. And then, as always, just remember that if A is positive, it faces up, so a happy parabola. And then if A is negative, it faces down. So below here, I've put together just a little bit of a cheat sheet that has combined all of our rules in one because it can be a lot. So I would go through and print that or write it down and just practice these, absorb it. It's a ton of information. And then in our next lesson, we will continue working with this stuff. And before you know it, it's going to become second nature and you'll be all set for grade 11.